In the last section, we spoke about how we could use memoization to dramatically improve the performance of our recursive solution right here. Remember, I can't say this enough. It is so incredibly likely in an interview that an interviewer is going to ask you to write out some problem or solve something, and then they are going to say to you, how can we improve the performance of this thing? If they say that, it is entirely likely, not 100% of the time, but it's very likely that they're referring to memoization. So this is a rather important technique, so stay tuned and let's get through this thing. Let's first start off by looking at a diagram that's going to help us understand how we're going to set up memoization on our Fibonacci function. So you and I are going to write a function that we are going to call memoize. So we're going to write a brand new function. This is going to be a generic memoization function. When I say generic, I mean that we can use this function that you and I are going to write not only for this Fibonacci thing, but for any other function that requires memoization as well. So I'm going to show you a technique that you can just repeat in any interview setting and it's probably going to work just fine. Okay, this memoization function is going to be a function. So this is a function right here. We are going to call it with a slow function, like our slow version of Fibonacci. So we're going to take the slow version of Fibonacci, we're going to pass it into this memoize function, and then the memoize function is going to return a fast memoized version of Fibonacci. So in other words, we're calling a function with a function that returns a function. There's a lot of functions floating around here. That's all I mean to say. So let's put together some code to kind of set up the system right here. So I'm going to flip back over. The first thing I'm going to do here is to rename our existing function to slow fib. So I want to make sure it's 100% clear that this is the slow version of our function. So I'm going to call it slow fib. Then right above it, we're going to declare our memoize function. So this is the memoizer. We're going to pass a function to it. It's going to return a new function that is dramatically speeded up. So whenever we call this thing, we're going to pass a function into it. So we will receive that as an argument called fn, short for function. Then we will return a new function right here. So this is going to be our dramatically faster one. This is going to be the one right here that is supercharged and is much faster than the base version. Now, to give you an example of how we would actually apply this thing in practice, excuse me. So we've got a slow fib right here, and we've got memoize right here. So an example of how we would use this thing in reality would be to do something like const fib equals memoize slow fib, like this. So we take our slow function, we're going to pass it to memoize, and then that's going to return a new function, assign it to fib, and then we will export that memoized version from this file. So now all we have to do is add some implementation to memoize right here. So remember that the entire idea behind memoization is that we declare some storage area, some place where we can record all the arguments that are used to call the function and the respective result from all those function calls. So right above our return statement right here, I'm going to declare a little object that is going to store all of our calls to the fast version of our function. And I'm going to call it cache because that's essentially what it is. It's a record of all the previous calls to this function and their respective results. Next, we're going to receive some arguments into the inner function right here. Now this is the part that's really hard for people to understand. Okay, so let's really focus on what's going on here. When we call memoize, we return a function. So this anonymous function right here is fib right here. This is the same as this thing. So at some point in time, we're going to want to call fib with like 5 or whatever it might be, right? So this anonymous function right here is going to receive the arguments that were actually intended to be sent to the slow fib function. So we do not necessarily know how many arguments will be passed to this function right here because we are making a generic version of memoize. You and I know that, yeah, we're going to use it with Fibonacci right here, which only ever gets one argument. But if you and I want to reuse this thing again in the future with some other function, maybe it takes 2, 3, 4, however many different arguments, we need to code this thing to assume that we might be receiving multiple arguments. So to do that, we're going to use a little bit of ES6 or ES 2015 code. we're going to say ... args. When we say ... args, that means I don't know how many arguments this function will be called with. Just take all the arguments and assign them as an array to this variable called args. So this is kind of some defensive coding right here. We are saying, I don't know how many arguments this thing will receive. All right, now the next thing we're going to do is immediately check to see if this function has ever been called with this particular set of arguments before. So we're going to look at the cache object. We're going to look at the key args. And if something exists there, then we're going to immediately return that, like so. So this is the actual caching part. This is the part where we say, hey, have we ever called this function with this particular set of arguments before and stored the result in this cache object? If we have, then just return that right now and don't do any other work, and especially don't call the original function. So this is the actual caching mechanism in play right here. Now, if we get past this if statement, then it means that we've never called our function with that set of arguments before. So we need to make sure we call that function, take the result, and cache it inside of our cache object right here. So we're going to say const result. So this is going to be the result of calling our slowfib function. We're going to call the original slowfib function, which remember was this argument fn right here. And then whenever we call a function with an array of arguments, which this is right here, we have to use the apply helper. So this is a little bit of back to basics with JavaScript right here. So we're going to call apply and pass in, actually, yeah, we're going to pass in this and args, like so. If apply right here is a mystery to you, I really recommend you flip on over to the MDN website. Remember, that's the Mozilla Developers Network website, and read up on apply a little bit, because it is kind of integral into how we make sure we call args here. Next, we're going to take the result from calling our slowfib function and store it inside of our cache object. So we'll say in the cache object, at the key args, store the result that we just created. And then right afterwards, we will return the result. Okay, so I know this is some crazy code right here. This is bringing back flashes of that spiral matrix project problem we worked on earlier. But nonetheless, this is a working, very generic memoize function right here that will work for many different functions that you'll create. Let's go check our test now and see what's happening. So over in our test file, when I run the tests, you can now see, oh, that's the wrong set of tests. Here we go, this is the right set. So you can now see that we can correct the Fibonacci or calculate the Fibonacci value for 15 basically instantly now, thanks to this memoization process. Now, I really do think that it still might be a little bit confusing on exactly how this is working. So I'm going to do a quick review on how Memoize works right now. If you've heard me talk enough about it and you're thinking like, Steven, I get it, I understand memoization, that's totally fine. Pause the video, move on to the next section. Otherwise, we're going to do a quick review. Okay, so quick review. We had said that, hey, calling slowfib all the time recursively is extremely slow. We need some way to improve the performance. So we came up with the idea of saying, before we actually call the slowfib function, we are going to create a little data store or a little cache object. The keys of that cache object will be the arguments that we were trying to call slowfib with. And remember that the arguments, when I say arguments, I'm talking about like some number here, 0, 1, 2, 3, 4, 5, whatever it is. So if we've never called slowfib with a particular number n before, then we will call slowfib, then we'll take n and the result and store it in this cache object. And that's what we were doing with this statement right here. But if we have called slowfib before with some given value n, then we'll look into our cache object, we'll find that, and then return it instead. So the whole idea here is that we are just avoiding calling the same function multiple times with with the same set of arguments each time. All right, now there's one other quick thing I want to mention here. Something that's not super great. Notice how we renamed the function here to slowfib, but inside that function we called fib. So we're not technically calling the function from within itself. We're calling this like kind of pseudo non-existent function. So a slightly better way of putting this together would have been to leave this thing being named as fib, and then to just reassign over fib right here. So this would have been a little bit better. So now we have a function named fib, and it's really clear to everyone like, hey, this thing exists, here's where it is. But then right after it, we immediately memoize that function and reassign it back to the variable fib right here. And the reason this is important is that when we do this right here and make sure that when we actually execute the original function and attempt to call fib recursively, these fib calls right here are not a reference directly to this function anymore. It's now a reference to the memoized version of that function. And so we just kind of avoided that discussion by changing the name of this thing to slow fib. I just wanted you to be aware that that's technically what's going on here. You do have to make sure that when you recursively call the function, you are calling the memoized version and not the original non-memoized version. Let me give you just a quick example of that. If we had been calling slow fib from inside this thing, fib contains a reference to the memoized version. Slow fib is always the slow version. And so even though we memoize this thing, when we call it recursively, it would be calling the slow version of fib, which would entirely defeat the purpose of what we were trying to do. We would be calling the wrong version of the function. All right. So hopefully this wasn't too bad. Let's continue in the next section, and we're going to move on to our next big problem.